Right, you've done some momentum problems and you're getting to be familiar with the problem solving process, using your units all the way through, explaining things, drawing things. And so we're going to do some speed and acceleration problems now. The first example here, a car travels 90 minutes on the highway. For the first 31 and a half minutes, it travels at a constant speed of 73.8 kilometers per hour. It then maintains 96.4 kilometers per hour for the remainder of the trip. What was the average speed of the vehicle in kilometers per hour? So I'm using this example problem to illustrate a couple points, okay? Namely the use of the formulas you were given, the velocity and acceleration formulas after one of our presentations, and then how some of those things work and how some of you might have some misconceptions and stuff like that. So we'll go ahead and start working this problem. And of course, the way we always start every problem is by what? Making a drawing, okay? So here's our car, okay? And as always, Mr. Harrison's simple cars, okay? Make it a hatchback this time, okay? And there it is, and it's traveling, and it has some speed and stuff like that, and we need to talk about that. But we'll go ahead and get started with some of our sign conventions. As always, we know it's going to go up there. Right and up is positive. Up and to the right are positive. And we always have to convey that each time. The reason, of course, is because we could change that, but we're not going to in middle school. Okay? So we got different variables we're going to define, but let's start talking about this a little bit first. So there's definitely a little bit of a trick to this problem. It's not just going down the road at a constant speed or anything like that. It's got two separate time periods when it's going two different speeds. Okay? So to kind of help us understand that, let's draw a timeline. Okay? And we'll say from this point to this point, okay, for a time of 31.5 minutes, the velocity, okay, and we'll label that velocity 1, all right, is 73.8 kilometers per hour. Okay. So obviously we should come over here and start delineating some of our variables and what they mean. Velocity. We know we're going to need a displacement or a distance. I'm going to call it a distance. Okay. We should put AV for average because it's asking for that. Okay. And then we could put 1 for time period 1 and 2 for time 2. Okay. And one other thing I want to go ahead and put in here, and that's a capital T. And we're going to call that total. And you'll see why we're going to do that in a little while. So there we have all of our signs and symbols and definitions that we're going to need for this particular problem. Okay. And I'm going ahead and box it in red so you can see that and refer back to it. If you're doing a problem on your own, you wouldn't really want to box it that soon because you might come up with something later on while you're doing the problem and say, oh, I need to define that. Okay. So the next thing now is finish our timeline from here to here. Okay. That's T2. And that is the remainder of the time. What is that? Do we know? Okay. Let's figure that out pretty quickly, right? So V2 is 96.4 kilometers per hour. Okay. So what is that time period? Okay, well, it's 90 minus 31.5 minutes. I ran into a little bit of crunch there, but you can see that minutes, okay? So we'll put that in there in just a few seconds, okay? All right. So what do we know? We want to find the average velocity, okay? Now, just so we're tracking what we're doing, I'm going to put a green box around that so we can see it, okay? So if you look on your sheet, okay, we're given the formula that average velocity is equal to the distance traveled over the time, okay? So in our particular case, we want the total distance traveled divided by the total time, okay? So that's where this total comes in, okay? This is the general formula. Now we've made it specific to our problem. So how do we find this quantity here, this distance total? Okay, well, we're going to have to break it up. The distance total is equal to the distance traveled during time period 1 plus the distance traveled during time period 2. Okay, so what is that? We can rearrange that equation, solve. If you take the equation, multiply time times average velocity, you'll come up with the distance. And so we can just do that kind of when we're substituting in. Okay, B1 T1 plus B2 T2. And I'm going to continue writing across the page here. So that's 73.8 kilometers per hour. I'm just writing it like that instead of kph, so I can start working on my units. The first one's 31.5 minutes. Well, here's a problem I'm noticing already. We have minutes and hours. What do we know? Okay. Well, we know 1 hour is equal to 60 minutes. Okay. Plus, going to run out of page here, so I'll just drop down, plus, okay, 96.4 kilometers per hour times 58.5 minutes. Where did I get that 58.5 minutes? Well, take 90 minus 31.5, because when it's on the road for 90 minutes, that means 58.5 minutes. And again, 1 hour is 60 minutes. Okay. And what I want to do is just kind of slightly move down and keep working. Okay. So when you punch in your little calculator there, you're going to get the total distance traveled to be 132.735. And what's our units? Well, let's look. If we take minutes and cancel with those minutes, and those hours and cancel with those hours, it's only going to leave us kilometers. That makes sense. That's what we want to see, right? You do the same thing over on this part here. Okay, your minutes and your hours and your hours cancel and give you kilometers. I really shouldn't say cancel. They divide out. Okay, hour divided by hour is 1, and so you just eliminate that 1 from it. And so, the velocity average, what we were asking the problem then, right, is equal to, again, the total distance divided by the total time. So 132.735 kilometers divided by, what's your time? You could say 90 minutes, or we can very quickly say, well, that's just an hour and a half. Okay, all right, and we're going to then get the average velocity. Well, I put an extra little g on my average here that I wasn't carrying up there. Erase that to make sure we're not being unclear. All right, and that's 88.49 kilometers per hour. Now, let me go ahead and box this to highlight what the answer is, okay? But while I'm doing that, I want to ask you a question. Could we have found that a different way? Because a lot of times when we say average, and we've talked about this in class before, would that mean something to us? Well, it means a little bit different here in physics than it does in math, okay? Some people, when you say, do you want to find the average, okay, they will ask, is this the same as the mathematical average. So can you add the two together, okay, and divide by 2? Well, let's take a quick look. If we say, okay, the velocity average is equal to v1 plus v2 divided by 2, we can say the velocity 1 is 73.8 kilometers per hour plus 96.4 kilometers per hour. Divide that by 2, or whack it right in half, right, Chelsea? Okay, and we get a V average of 85.1 kilometers per hour. Well, that's not the same answer. And it's not correct. Okay? So doing it with the equations is the correct way, and trying to shortcut it is not the correct way. Okay, so I'll pull out so you can see the whole thing real quickly. If you need to copy it. Okay, so that's how you work that problem.